Bismillahirrahmanirrahim. Assalamu alaikum. This is Uruj Sakib from Happy Home O-Level School. In this video, we will learn how to solve simultaneous linear equation with rational coefficients. We will be using elimination method. Before starting, let's do a quick recap of elimination method. As you can understand from the word eliminate, it means to remove something. In this method, we remove one of the unknown to find the value of the other unknown. In this method, we have to have the same coefficient of the unknown. If we don't have, then we have to make the coefficient same of the variable which we want to eliminate by multiplying any or both equations. If the terms which we want to eliminate have same sign, then we have to subtract them. If the terms which we want to eliminate have different sign, then we have to add them. These are the important points which we have to remember while solving the simultaneous linear equation by elimination method. Let's start our today's main topic, solving the simultaneous equation with rational coefficients. Take example of the problem x plus 1 upon y plus 2 is equals to 1 upon 2. This is our first equation. X minus 2 upon y minus 1 equals to 1 upon 3. This is our second equation. You can see both the equations have fractional values. Our first step is to remove the fractions from the equation. And we can remove these fractions by cross multiplying them. Let's take first equation first. In equation number 1, x plus 1 upon y plus 2 equals to 1 upon 2. We'll cross multiply the denominator. So x plus 1 will be multiplied by 2 and y plus 2 will be multiplied by 1. After multiplication, we will have 2x plus 2 equals to y plus 2. We simplify the equation further and 2x plus 2 minus 2 equals to y. After simplifying it further, we have got the result as 2x equals to y. Now you can see there is no fraction in this equation. We call it equation number 3. Now take the second equation. X minus 2 upon y minus 1 equals to 1 upon 3. Again in this equation, we have fractional values. To remove, we will cross multiply them. So x minus 2 will be multiplied by 3 and y minus 1. After multiplication, when we open the brackets, we will have 3x minus 6 and equals to y minus 1. When we simplify it further, 3x equals to y minus 1 plus 6, which is equals to 3x is equals to y plus 5. This is called the fourth equation. Now you can see our first and second equation have been changed into equation number 3 and 4 when we have removed their fractional values. Now we will be applying elimination method to find the value of one unknown. In both the equations 3 and 4, you have noticed the coefficients of y are same. So when the coefficients of y are same, they also have the same sign. So we are going to subtract them to eliminate y. Equation number 4 is 3x equals to y plus 5. Equation 3 is 2x equals to y. Both the terms of y are positive, that's why we are subtracting them. When we subtract 2x from 3x, we got x, And after subtracting, we are not having anything as y is being eliminated. So x equals to 5. Now we have got the value of one unknown. This value will be substituted in the equation to find the value of y. 2x is equals to y. This was our third equation. When we substitute the value of x as 5, the value of y will be 10. You see, this is a very simple method in which we can find out the values of unknown. Let's take another example. Now the equations we have 2 upon 3x minus 2 upon 5y equals to 1 upon 2. We call it our first equation. 3 upon 5x minus 1 upon 7y equals to 4 upon 3. We call it our second equation. As you can see, both the equations have fractional values. We have to eliminate one of the variables to find the values of the unknown. And to do so, the first step is to remove their fraction. We will remove their fractions by taking out their LCMs and then cross multiplying. We'll take equation number 1 first. 2 upon 3x minus 2 upon 5y equals to 1 upon 2. If you look at this equation, x and y both are having fractional coefficients. To remove them, we have to find out their LCM. The LCM of 3 and 5 is 15. So we have to multiply it 2 upon 3 by 5 and 2 upon 5 by 3 so that both the denominator will turn into 15. After multiplying, we'll have the equation as 10x minus 6y upon 15 is equals to 1 upon 2. Now we will cross multiply to remove the fraction from both sides of the equations. 10x minus 6y will be multiplied by 2 and 15 will be multiplied by 1. After multiplication, we will have our result as 20x minus 12y equals to 30. We call it our third equation or equation number 3. Let's take the equation number 2 now. 3 upon 5x minus 1 upon 7y equals to 4 upon 3. Again, in this equation, the x and y coefficients are in fractional values. To remove them, we have to find out their LCM. The LCM of 5 and 7 is 35. It means we have to multiply 3 upon 5 by 7 and 1 upon 7 by 5. After multiplication, we will have 21x minus 5y upon 35 equals to 4 upon 3. Now, to remove the fractions further, we will cross multiply. So 21x minus 5y will be multiplied by 3 and 35 will be multiplied by 4. After multiplication, we have 63x minus 15y equals to 140. We call it our fourth equation or equation number 4. Now you can notice that equation 3 and equation 4 are both simple equation without any fractional values. We will now use elimination method to find the value of one unknown. Now we will make the coefficient same of y. Both the coefficients of x and y are unknown. Right now we are planning to eliminate y so that we have to have the same coefficient. For this purpose, we have to find out the LCM of 12 and 15. The LCM of 12 and 15 is 60. It means our both the terms of y must have 60 as the coefficient. To change equation 3 with the coefficient 60y, we have to multiply equation 3 by we have to multiply equation 3 by 5 and equation 4 by 4. So after multiplication, the equation turns into 252x minus 60y and 560. This is our equation 5. And after multiplying equation 3 by 5, it turns into 100x minus 60y equals to 150. We call it our equation 6. Now you can see both equation 5 and 6 have the same coefficient of y and both are having same sign as well. When the signs are same, we have to subtract. Let's see. Subtract equation 5 and 6. (252x minus 60y equals to 560. This is our fifth equation. 100x minus 60y equals to 150. This is our sixth equation. When we subtract, we change the sign. The answer is 152x and equals to 410. The value of x is equals to 410 upon 152. When we reduce the fraction, the value is 205 upon 76. Now we substitute the value of x in any of the equation to find the value of y. 100x minus 60y equals to 150. We substitute the value of x as 205 upon 76. After simplifying, we get the result as 5125 upon 19 minus 150 equals to 65. When we simplify it further, we will have the result 2275 upon 19 equals to 65. The value of y equals to 455 upon 228. I hope you all have understand. Thank you.